today. Alright, so our number that we left off with was number 4. Alright, so number 5 says a lab ordered a shipment of mercury (197), which has a half-life of 3 days. It took 15 days to arrive and only 1 gram remained. How much did the lab originally start with? Alright, so we're looking at this one. First of all, does this one deal with quantity or does this one deal with time? So this one deals with quantity. Alright, so we're looking at the first type of problems that we did yesterday where we found the number of half-lives first and then we set up our chart. Alright, so let's see what our information tells us. It tells me that we have a half-life of 3 days. 15 days is how long it took to arrive. And when it got there, I only had 1 gram left. So in order to find my number of half-lives, all right, we do the time covered, which is 15 days that it took to get there. Divide that by our half-life, which is 3 days. So that gives me how many half-lives? 5. Alright, now typically from here we would set up our chart. We'll zoom out a little bit. We would set up our chart and we would go 5 half-lives in. The difference with this one is that it told us how much was left and we're trying to figure out how much we started with. So we have to do the chart backwards basically. So we'll draw our chart in and this is where we usually start at 0. And normally I would go 5 half-lives down. Alright. And normally we would put how much we start with here and then we would divide by 2 all the way down. But instead we're going to work backwards on this one. So after 5 half-lives, it tells me that 1 gram remains. So I'm going to head up this way. If I'm heading up this way, I'm not going to divide, I'm going to what? Multiply. So at 4 half-lives, I would have had what? 2. At 3, I would have had 4. At 2 half-lives, I would have had 8. At 1 half-life, I would have had And when I started, I would have had 32. All right, so we got to go all the way up to that 0 mark, and I would have had 32 grams of mercury 197 when I originally started. All right, so not too bad. You just have to remember to work the other direction. All right, let's look at the other one that is a little different than what we looked at yesterday. This one says if the half-life for nitrogen 16 is 21.6 seconds, how long will it take for 1/16 of the sample to remain? All right, is this a quantity or a time? This is a time problem. So with a time problem, we have to make the chart first in order to find the number of half-lives. So I've got 0 half-lives. That's my start time. All right, and let's look and see what information they gave us. They told us that the half-life is 21.6, and the only other thing they gave us is a fraction. All right, so they didn't actually tell us how much we were starting with, right? But they want to know how long it will take for 1/16 of the sample to remain. So when we start off then, we're going to say we start off with a whole sample, right? So we're just going to say 1. Starting off with 1 whole sample. And at 1 half-life, how much would I have in a fraction left? A half. All right, at 2 half-lives, we'd have a 1/4. At 3 half-lives, we'd have an 1/8. At 4 half-lives, we'd have 1/16. All right, everybody know the trick now to half a fraction. You just multiply the bottom by 2. Okay, so if you had to go further than 4, you could just multiply 16 by 2. It would be 1/32, all right? 1/32. So you just keep doing that all the way down if you're dealing with a fraction form. All right, so that tells me that it would have taken 4 half-lives in order to have 1/16 of our sample left. So now we're going to say 4 half-lives times 1 half-life, which is 21.6 seconds. So how many total seconds, or how long total would it take? Good. 86.4 seconds would be my answer.